Hi everyone. In this video, we're going to be doing Cisco Packet Tracer 6.2.2.4, titled Configuring IPv4 Static and Default Routes. To begin, we'll want to open up our Packet Tracer activity with the instructions. I've already completed this, so I'm going to reset it, and we're going to walk through it together from scratch, from the start. Alright, so the objectives, we're first going to evaluate this network and determine the need for static routing. Second, we're going to configure the static and default routes. And then third, we're going to verify connectivity once we're done. As it's set up right now, each of these networks are completely isolated from the others. We have no routing between networks. And so that's the first thing that we're going to configure on here, but before we do that, we need to verify that we do in fact not have any connectivity. So a little bit of background about this activity. We are going to be configuring these static and default routes to enable communication between these networks. We are going to create 4 different static routes: a recursive static route, a directly attached static route, a fully specified static route, and a default route. So looking at the network topology, we have 5 networks. We have one here, a second here, a third up here, and a fourth between these 2 routers, and a fifth between these 2 routers. So we can see that R1 has 2 networks directly connected, the switch and PC here, and then router-to-router network here. R3 is the same way, router-to-router network here, and the switch and PC here, so 2 total networks directly connected to router 3. Router 2 is slightly different because we have 2 router networks, so we have a router-to-router here between R1 and R2, a second router-to-router between R2 and R3, and then our third network is the switch and PC up at the top here. So how many static routes are required by each router to reach networks that are not directly connected? So for R1, how many static routes do we need to reach this network and this network, basically? So R1, we need to set up both of those, 1 and 2. Router 2 actually has 3, because we have here, and we're going to set up for here so that it can route in and out, kind of act as a gateway. And router 3 is going to have 1 and 2. Sorry, I think I actually just did that backwards. Router 1 requires 3 to reach 1 up here, 2 to reach this router, and 3 to reach this network. Router 3 is going to be the same way. We need 1 to reach this network, 2 to reach this network and transmit across this network, and then the third is to reach this network. R2 only requires the 2 because it's already directly connected here. We just need it to be able to reach here and here. Alright, so we ping from PC1 up to PC2, and then from PC1 up to PC3. So we'll go to the desktop command prompt, and the address for PC2 is 172.31.0.254. And we can see that the host is unreachable. We haven't set up any routing, so it can't even get to that network for communication purposes. When we ping to the third PC, 172.31.1.190, we should get the same thing. They can't leave their current networks yet. So that concludes part 1. We obviously need to set up some routing. So, on to part 2, we're going to set up these static routes. Alright, so step 1, configure a recursive static route. And a recursive static route is basically just a next hop route. And why does a recursive static route require 2 routing table lookups? The answer to that is that it must first look in the routing table for the destination, and then it goes to the destination. So part C here in step 1 is configure a recursive static route to every network not directly connected to R1, including the WAN link between R2 and R3, including this segment here. So we're going to come into the R1 command line to get started. Enable and go into configure the terminal, the global exec mode. We're going to set up IP route 172.31.0.0 with subnet 255.255.255.0. And the next hop is going to be 172.31.1.193. So that takes care of the first one, which is going to let it connect up to this network. So we'll do the second one next. 172, sorry, let me restart that. IP route 172.31.1.196. And this is a /30, it looks like. 252 on the end of that subnet. Mask. Next hop 172.31.1.193. And that allows it to connect down to here. So this is the router to router between R2 and R3. And the third one that we're going to set up is for network 172.31.1.128. And this is 255.255.255.192 for the subnet mask. Next hop will be the same, 172.31.1.193. Alright. So now that we have that configured, that was to get it over to here. So from R1, we're directly connected here and here. So we set up routes to get it to here, here, and here. So we didn't set up the directly connected. Alright, so the next step here is to test connectivity to the R2 LAN and ping the IP addresses of PC 2 and 3. So we're going to do that from PC 1, and we're just going to ping out to PCs 2 and 3 one more time. And these should still fail, because although R1 has a route out to R2 and R3, R2 and R3 have not configured a route back to R1. And so we'll expect all of these to time out. I'm going to speed this up a little bit and interrupt that because we can see that it's going to continue timing out. This one will do the same. After we see 2 timeout errors, we'll move on. And there it is. You can wait and watch all 4 if you want, that's up to you. I'm going to move on to step 2 here in part 2, configuring directly attached static routes on R2, which is this router. And so it begins with question A, how does a directly attached static route differ from a recursive static route? The answer to that is that a directly attached static route relies on its exit interface in order for packets to be sent to its destination, while the recursive static route uses the IP address of the next hop router. So the next hop, basically from R1, we were configuring that to hop over to R2 and continue that way. So we're going to go ahead and configure directly attached static routes for R2 for every network not directly connected, which is basically this network and this network. So we'll jump into R2's command line interface and get up to the global exec mode. So we're going to set IP route 172.31.1.0 with subnet 255.255.255.128. And here's where we see the difference between a directly attached static route compared to the recursive that we've already set up. The recursive, we had the next hop IP address. For the directly attached static, we use the interface, which in this case is going to be serial 000. Alright, and you can see the little message it gives us here. Default route without a gateway. It's because we're pointing it to this interface rather than a router IP address. But since this is point-to-point, we should be okay. And then we're going to do the same thing again for IP route. And let's take a look at this first. So we set it up to come over to this network off of serial interface 000, which should be this port right here. You see it flash there for just a second. So we're saying that network traffic to that network is going to come out of this interface. And so it's going to come across this line over to R1 to get to that network. We're going to configure the same thing out this side off of this interface, serial 001. So we set IP route 172.31.1.128 with a subnet mask of 255.255.255.192, and that's going to go over S001 or serial 001. And we'll get the same message, but remember that these are point-to-point, router to router, so we're okay. The next part of step 2 here is question C, which command only displays directly connected networks? And for that, we will come out to our privilege exec mode, and we're going to run this command, show IP route connected. And this will only show us the directly connected networks, which from router 2, we have these 3 networks directly connected, which we can verify by looking, 1 here, number 2 there, and the 3rd is up here. So that's exactly what we would expect to see giving it that command. And we can even double check and make sure that our interfaces are correct. We have gigabit Ethernet 00, serial 0, and serial 1, which we've just created these. And gigabit Ethernet 00 will be this port right here. Alright. So the last question for this step is question E. When viewing the entire routing table, how can you distinguish between a directly attached static route and a directly connected network? A directly attached static route will be labeled with an S, and a directly connected network will be labeled with a C. So we pull this back up. These are directly connected with that C. If it was static, then we would see the S. Alright. And on to step 3, configure a default route on R3. And so the first question is, how does a default route differ from a regular static route? And the answer to that is that a default route, or a gateway of last resort, in Cisco terms, the default route is the network route that is used when no other known route exists for a destination network. So basically it says if it doesn't have any route to a specific network, it will default to a specific interface or a specific next hop, whatever we set it up for that. So we are going to go to step B, or part B here, configure a default route on router 3 so that every network not directly connected is reachable. So we come into router 3 command line interface, go back up into the global exec mode, and we give the IP route 172.31.0.0. My mistake, that should be all zeros. 0000 with a subnet 0000, and we tell it that everything is going to go out through serial 001. And if we come back and look at router 3, this interface should be 001. You can see it flash there for just a second. So all traffic that doesn't have a specific route is going to go out through that interface. And again, it gives us this message. We are point-to-point, router-to-router here, so we're okay. Question C, under step 3 here. How is a static route displayed in the routing table? And we can actually go take a look at that. We'll give it the command show IP route static, and we'll see that it starts with S to show that it's static. Alright, so onward to step 4 here. We do have a note in the instructions. Packet Tracer does not currently support configuring fully specified static routes. Therefore, the documentation... Therefore, in this step, we will just document the configuration for fully specified routes. So question A states to explain a fully specified route. This is a route that would include an interface, a network address, and an IP address for next hop. So it includes everything. It says go out of this interface to get to this network and use this IP address for your next hop, rather than just the parts that we've been using to build our routes up to this point. And then we are asked which command provides a fully specified static route from R3 to the R2 LAN up to here. I'm going to go ahead and pull open a notepad so that I can show this command. Alright, and so the command for that would be in the global exec mode on router 3. So you would see something a bit like this, showing that we're in the global exec mode. Your command would be IP route 172.31.0.0, subnet mask 255.255.255.252. So we're showing it how to connect out, and we are going to tell it to use serial interface 001, and the next hop would be 172.31.1.197, which is this interface on R2. So that would be the full command for a fully specified static route from router 3 to the LAN connected to router 2. But as it mentioned, Packet Tracer doesn't support this at this time, so I'm showing it in a notepad. Up next, we need to write a fully specified route from router 3 to the network between R1 and R2, so to this network. I'll be doing this again in Notepad. And so, again, you'll want to be in the global exec mode on R3, which we saw looked like this. And the command is IP route 172.31.1.192 with a subnet mask of 255.255.255.252, which is that /30. We're going to continue using S001, and your next hop would be 172.31.1.197, which again tells it to come out to this interface. And then it would use the next route from R2 to get over to this portion of the network. Part D then asks us to write a fully specified static route from R3 to the R1 LAN. Sorry, so that last one was up to the R2 network, not the R1 network. We're going to do the R1 now. And so from the global exec, it's IP route 172.31.1.0 on 255.255.255.128 using serial 1 with the next hop 172.31.1.197. So again, that tells it to get to this network with this subnet mask, you're going to go out on serial interface 1 to this IP address for your next hop, which is this interface on R2. So once we finish with those commands, step 5 asks us to verify static route configurations, and so we need to use the appropriate show commands to verify the correct configurations. And there are 3 primary show commands that you can use for this. The first one would be show IP route on a router. The second is show IP route static. And the third that you could use would be show IP route and then whatever the network address is. So you can use these to verify that your routes are set up and configured properly in your routers. Alright, and the last part here is to verify connectivity. And you can do this with a ping. I am actually going to do this with a trace route, so we can actually see as it goes along through each hop. Trace route 172.31.1.190. And so this shows us first hop goes to this IP address 172.31.1.1. The second hop takes us to 172.31.1.193. The third hop takes us to 172.31.1.198. And the fourth hop gets us to our destination. So we can see how it's going through this whole network, one step at a time. And it looks like that's everything following the instructions. If you follow it along, you should also be sitting at completion rate of 60 out of 60, or 100%. And all in about 21 minutes walking through with the video. So if you have any questions or comments, please feel free to leave them below. Otherwise, I will see you in my next video.